Okay, we're still on our Easter break, and this is part 2, where we're just setting up and solving volumes of revolution using washers. So on this one, it's number 21, which I didn't assign, but I think I'm adding 17 and 19 to your work, which I will tell you when we get back. And so this one is like one of those. So number 21 in that same set, which I haven't assigned as of yet. So x equals y squared, and x equals 4. I'm going to take that, I'm sorry, I can't read my writing. X equals y squared, and x equals 4. Yeah, I think that is right. I'm going to take the area enclosed by those two graphs and revolve it around x equals 5 and find the volume of that solid. So x equals y squared is a parabola that opens to the right, and x equals 4 like this. So to find that in your calculator, you need a y equals. So taking the square root, you're going to get y equals plus or minus the square root of x. So you're going to have to put that in your calculator. y1 equals the square root of x, and y2 equals negative square root of x. That's how you get the plus and the minus into your calculator, and then it'll give you the entire graph. Or you could set up a quick table as well. So now that I have that, I'm going to revolve this around x equals 5. So this is y equals 4, so I'm interested. I usually dot the line I'm going to revolve it around, not this one. So I'm revolving around 5, and so this colored in area, enclosed by the graphs mentioned, is going to create its partner over here, reflection, and it's going to create a three-dimensional shape, which is sort of a bowl, but it has a hole in the top and a hole in the bottom. So I'm not sure what it is, but there it is. Okay, so we need the volume of this, and this has an outer disk and an inner disk. So see if you can pick a spot and draw the outer and inner disk. You'll notice when we're revolving around a line x equals something, the disks are going to pile up in the y direction. When we revolve around y equals some value, the disks pile up in the x direction. So did you draw one? I'm going to draw this one, and that's the outer, and this is the inner part. And I'm going to put the points of interest that'll help me with the radii darkened. Alright, so once I see that I'm going to integrate by adding these washers. Here's one of them. I'm going to stack them up from way down here where they're quite small. They're just going to keep stacking on top of one another from way down here to way up here. So what is the lowest point? Well, this point is where x equals 4 and our function intersect. So if I put 4 into this equation, I get a plus 2 and a minus 2. So this point up here is 4 over 2 up, and this one is 4 over minus 2 down. So that tells me that I'm going to stack these up in the y direction, so from -2 to 2. But I'm going to make the integral a little easier for myself by, I see it's a symmetrical solid, the half of it above the x-axis and half of it below. So I'm going to double from 0 to 2. And there's my pi. And if you didn't double it, you wouldn't have this 2 here, and you'd have a -2 to 2. And that's fine, especially if you're putting it in the calculator, that's fine. But I think I asked you to do at least one integral by hand, and just to keep it fresh, how to take integrals. So this would simplify it if you're doing it by hand. All right, outer radius squared minus inner radius squared. And are these dy or dx? Well, here's the thickness of one of the washers. The distance between my thumb is read on the y-axis. Very small. So it's a dy. All right. So I'm going to do this one in terms of y. All right, let's see what the outer radius is. Try to draw in the outer radius. Actually, I guess I'll draw the inner radius first just because it's always eclipsed by the outer one. It's easier to see if I draw the inner one first. So here is the inner radius in red. My red doesn't like to write on top of where I want it. All right, there's the red. And notice, no matter where the disk is, the radius is going to be the same. So that's nice. Since this value was 4 and we revolved around 5, do you see that the radius for the whole, the inner radius is always 1? All right, so 1 squared, which won't affect it being a 1, but if it wasn't a 1, you'd have to recall to square it. So now we need the outer radius. All right, so I'll try my green marker here. So the green is going to go from my point of interest to here. So, all right, so I need that value. That's the outer radius. It's somehow connected to this point. No matter where I put that washer, it's still going to be involved with this point along the function somewhere. So that point is over x up y. Right there. So, can you get this green value? Well, from here to here is x. And up is y. But I'm interested in x this time, so I can pull this arrow up here. So here to here is x. From here to here is the value 5. But I want this. Do you see it's 5 minus x? I hope so. 5 minus x is the value of the outer radius. However, I have to work in y, so I check my function and I see that x is the same as y squared, which is not too hard to work with. So everywhere there is an x, I replace it with a y squared. All right. We have to square this binomial, which isn't too bad. And subtract 1. Integrate. So we end up integrating from 0 to 2. 25 minus 1 is 24. I'll put it in descending order. Alright, so that one's not too hard to integrate, and especially if you've doubled it and used 0 down here. Either by calculator or by integration and multiplying through by 2 pi, you should get 832 pi over 15. Alright, and these are, always these volumes are some units cubed. Alright, so hopefully reviewing how this works, it's pretty repetitious. Each one has to be sketched so you can find the inner and outer radius, but it is done the same every way. So I showed you one going around the axis of revolution was x equals something and one where y equals something. So in both cases were kind of the worst case. So I think you should be prepared to do them now. Here's the one from the Math League that showed up, lo and behold, on our last test. So let's see. They had y equals x squared, and they wanted the area enclosed by y equals x squared, y equals 3, and I believe it was the y-axis, that area. If I don't remember right, I'll correct myself later. Y equals x squared, 1, 2, 3. Is that right? I don't think that was right. Let me go peek at it. Hold on. Solid form by rotating around the y-axis. So we're going to go around the y-axis. The area bounded by y equals x squared, y equals 9. That's what it was. So this is 9, not 3. I didn't think I was remembering right. And the y-axis. So the solid form by rotating about the y-axis, the region bounded by y equals x squared, y equals 9, the y-axis. So this area is going around this. Is going around the y-axis. So it's going to create a solid bowl. So we don't need washers, there's no holes, so we have discs, and here's a disc that I'm most interested in. Here is the radius that will help me. And notice that radius is related to this point on the function, and it's x over y up. We went over x and up y. Alright, so let's set up the integral. So the integral is going to have all of these penny type circular discs, and they're going to stack up from down here up to here. So they're going to go from 0 to 9. Pi, the radius squared, and these are the thickness of each of these pennies is red on the y-axis, dy. So what is the radius? The radius is, we went over x and up y. So no matter where I put this disk, it's always got a radius of the x value of the function. So be like this. However, we have to work in y. So we go up here and we see that we have to rearrange this slightly to get x value for x. So if I take the square root of both sides, I get x equals the square root of y. So I'm going to rewrite that. Square root of y, quantity squared, dy. They made it nice and sweet for you. So you end up integrating from 0 to 9 of y dy. So that's y squared over 2. I'll grab the pi in a minute. From 0 to 9 is 81 over 2. And 0 won't create anything to subtract. So 81 pi over 2. I don't think anyone got that. Sorry to say. I couldn't see your work. A lot of it must have been on another paper. So if you could alert me to what you did, I could come to understand your thinking. So 81 pi over 2. All right, good practice. And the assignment, in case you didn't bring your book home, let me just shine a light on it. Sorry to walk you in a dizzy manner through my house. All right, here are the problems. and I will tell you which ones we were assigned. It's 11, B and C. They kind of have red checks on them. 12, A, B, C, and D. 13, A and B. 14, A and B. And I promised I was going to add 17 and 19, which are down here. You need the directions for 17 and 19. All right, so I hope that you can make some headway on that. I hate to give homework over the break, but we are on a time limit for those who are taking AP tests, and it'd be good to come in with those attempted and questions ready. All right, feel free to email me, contact me if you need to see another one done from this list. If you're stuck, I am open to do that so we can make some forward progress. All right, I hope you're having a relaxing time and that this assignment is not too aggravating. All right, I will talk to you when I talk to you. So carry on, class. Goodbye.